Okay, think you're able to see my screen. Uh, 1 second, guys. Yeah. Uh, Second, someone is in the lobby. Yeah, fine. Today we are going to discuss about multi-threading enhancements. Okay. So whatever we have discussed till yesterday, those are the at the time of initial time whatever the Java version was released. Those are the initial versions. Later, so they have added some more enhancements in the multi-threading concept. So those are we'll discuss now. Okay, thread groups. Okay, now thread groups means till now we are creating of if you have two tasks if you want to perform two threads, then we are creating of two threads separately, right? So, and we are executing of them separately. But now in this case, we are going to can start multiple threads at a time. How many number of threads you want? That many number of threads we can create as a group, and then we can execute them as a group. That will call it as a thread group. Okay, based on our requirement, we can group all the threads. Based on our requirement, for our requirement, I want to execute of 10 threads at a time. Okay, we can group all 10 threads as a single unit, and then we can run them. Okay, this group of these threads will call it as a thread group. Okay, and these thread groups can contain of subthread groups also. One thread group can contain subthread groups or threads, anything it can contain. Okay, now we will take some examples also. Okay, and why do we need thread groups? Why do we need of thread groups means so it will give us some if you want to stop off all the threads in one shot. Okay, then we can stop thread group, then it will under that whatever the threads is there, all thread will be stopped. If you want to suspend of all threads, then we can suspend. So if you want to do of some common operations to all the threads which is particular to a some thread group, then it is a best choice for that. Okay, and each and every thread is belongs to a some thread again. Okay, let's say we are creating of some thread. Let's say class uh, test. So main thread. Okay, it is of main method. So what is the default, what is the thread group, thread name of the thread which is running of main thread is main method is there is a thread called main thread. If you want to know that, thread dot current thread dot get name, it will give of current thread name. Okay, current thread name. If you want to know, every thread is belongs to some group. Okay, if you want to know of the main thread is of group of which thread group. Okay, now dot get thread group name, thread get thread group. If you want to know the main method belongs to which thread group, okay, then in that case it will give up the main thread belongs to which thread group. Okay, even it is belongs to the thread group of main thread is also a main. Okay, and if you want to know, all threads belongs to some group. Okay, so under that, and one more thing, so all thread groups, every thread groups are belongs to under subgroup of one group, that is called as a system group. The main parent group for all threads is system group. There is a system group is there, so under that all these are subgroup. If you want to know that, now let's get parent get parent group. Let's try for current thread group dot get get thread group dot get parent dot get name. What is the name of the parent group that you want? Okay, the it is a main thread is running. Main thread is belongs to main thread group. That main thread is group of subgroup of which group? What is the parent group of main thread means? It will give that. Let's see. It is giving of system group. It is giving of system group. If you want to know that main thread group, and main thread group belongs to which subgroup of means, then we can call of get parent. So this method will return the parent of that group, parent of that group. Okay, now we'll create of how many ways that we can create, how many ways that we can create a thread group. So we are telling of a thread group is contains of uh, some group of threads. It is of some group of threads, right? So if you want to create some three threads as one group, then we can create that. So and if you are not giving of any group name for that, so wherever we are creating that thread group, that the group parent group of that one is current running thread group only. Okay. Now let's see, we'll take off one example and then we'll see. Okay. Let's already have created of, yeah. Let's see this one system data. Okay. 1 second. Yeah. So what I'm doing, if you want to know of current thread group, if you want to know of current less. Okay. If you want to know the current thread group, thread dot current thread data. So who is going to run the main method? Who is going to call JVM? So even JVM also will create one thread. That thread is called, if you want to know the thread, that is the main thread. That main thread is belongs to which thread group? If you want to know that, thread dot current thread dot get thread group dot get name. What is the name of the thread group that is running main thread? Okay, it will give that. Now if you want, let's see, it will give, it is giving of main. So even the main thread group is belongs to, is any child group, is there any parent group is there for the main thread group? Now let's see for that. Okay, second guys. Now write off one more system dot println thread dot current thread is a common, okay, which is running. Now dot get thread group, that is the current minimum thing. So to get the name of the current thread group, the parent of this group, get parent, call that method get parent method. Then it will give off main thread main thread group. What is the parent thread group of main thread group? It will give that. And if you want to know that name, dot get name. Okay, we are calling of chained methods, guys. We are calling of chained methods. Let's see. First one it will give of main thread group, and second one is giving of system group. Okay. Now we'll create our own groups. We'll create our own groups, and then we'll check whether the which is parent group and child group, all those things, the relation. Okay. Now, there are two constructors is available in the thread group. There are two constructors are available to create of any thread group. Let's create of one thread group. Thread group T equal to, okay, or TZ. Thread group TZ equal to new thread group. See, inside this, we are having two thread group of string name. The string name is means that it is a thread group name. It is of meaning is group name, thread group name. Let's take it off. Group name is some uh, IBC group. IBC parent group. Parent group, just assume IBC parent group. So inside this group, we can create of some threads. Okay, if you want, we can create of some threads also under that. And now let's create of system dot out dot println of thread dot tz, tz thread, right? So thread group tz dot get parent. What is the get parent? Already we created thread group. So what is the parent group of this IBC parent group means? Let's see. Get a parent. So where exactly we have created this group? Under main thread. Under main method is there, right? Who is going to create? Who is going to call? JVM is going to call. So on what basis it will create internal one? Main thread. Main thread is belongs to main thread group. Okay. Now dot get name. So we are created this thread group under main thread group. Okay, and we didn't give in any group name here. If you are giving any group belongs to this thread group, then that is the parent group of this group. If you are not giving whatever the currently running thread, it is of main thread. Even this thread group is also belongs to that group. Okay. Now let's see. It will give off parent is. Now let's see. It will give off main thread. It is giving off main thread group. Okay, if I want to change my main thread group of the current thread, okay, then let's see that. Create one more thread, and I want to make IBC parent group as a IBC parent group as a parent thread. Okay, parent thread group. Let's create a copy of this one, and IBC child group. Just assume child group. Now, if you are creating like this, then the parent group of this group will become as main thread only. Okay, I don't want that. If I want to make this as a parent group for my IBC child group, then in that case, we need to give the this thread group as a first parameter, and second parameter is the name of the thread group. This is the parent, this is the child. Okay, now if you want, see the IBC child group parent is tg1 dot get parent dot get name. Now this tg1 group is going to give the parent thread group name as IBC parent group. Now let's see. It is going to give as IBC child group parent is IBC parent group. Okay, IBC parent group. So if you don't want to give the thread group name, then whatever the current running thread, whatever the currently it is running under main thread, then the parent thread of IBC child group is now it is also in this case also it is going to give as a main thread. It is going to give as a main thread because we are not assigning this group to any other thread, parent thread, specific parent thread group we are not giving. So by default it will consider as wherever it is running this code, that is the parent group name. Okay, that's what this one. Okay, now next let's go to document. These are one is thread group G equal to new thread group. This is the name. This is the name of the thread, and the parent of the new group which we are going to create here is the thread group of currently running thread. Thread group of currently running thread. Currently running of main thread. Okay, main thread group is belongs to main thread group. Okay, that's the reason it is going to give us the main as the currently running thread group. Okay. Thread group name with the new thread group of this is of thread group parent group name. Okay, and this is the name of the group, the child group. Okay, now this group is belongs to and child of this group, child of the group which we are giving here. Okay, now the parent of this thread group is specified in the thread group here, whatever that is. Okay, whatever that is here. Now that's what we are seeing. That's what we are seeing. It is of giving of parent thread group and parent of the current running thread group, and it is of creating of some parent thread, and that belongs to we are giving as a child of we are creating one more child of that parent group like this. Okay, this is a way of creating of thread groups. Okay, now we will test some scenarios also. We will test some scenarios also by creating of thread groups also soon. Okay. Now, next, what are the important methods of What are the important methods of thread group class? Okay, we are creating thread groups, right? So under this thread group, we can create of multiple groups, multiple threads. Let's say, for example, let's say class thread group test 3. Create of some threads. Okay, now let's create it. Now create one thread group. Okay, thread group is equal to new thread group. New thread group of give some name. Okay, this of IBC group. Okay, I'm giving of some IBC group. Now, so right now this is a group name is there, but we don't have any threads. Okay, let's create of some threads. Okay, thread T1 equal to new thread of new thread of so I want to make that T1 thread belongs to this thread group. Okay, now give TG, and I want to give of name of the thread also. Give as thread 1. You can give as thread 1 some thread name. Okay, whatever you want, you can give it. Okay, now create of another thread again. Create of another thread. Let's create of another thread. Now this is also belongs to same TG group. Now it contains of some threads. Okay, it contains of some threads. It contains of two threads. T1 and T2 belongs to IBC group, these two threads. Okay, and by default, the priority of these two threads system dot out dot println of T1 dot get get priority is default priority will get as 5, right? Default priority of each thread is 5. Now let's do. Both are giving us 5, and if you want to know that. Out system dot out dot println of easy dot get get see we're having some count will be there, some we're having some methods, not get remove without get any active count. Let's give active count. What is the uh, thread count inside that active? Right now there is no active count. Okay, so if you want to know the any active count, then it will give active threads, active thread groups, threads present in that group. Okay, it will give off that count. And if you have any child groups is there inside that, we can get off that active child groups also by using there are some methods, tg dot so get or yeah, active group count. Active group count. It is going to give off all the. It is going to give off all the active thread groups present in that group. It can contains of subgroups also, right? So it will give off all that active groups in that group. Now, if you want to know the priority of thread group, if you want to know the priority of a group, then we can get that priority. Okay, let's system dot out dot println of tg dot get max priority. Get max priority. Let's check it. By default, max priority is 10. By default, max priority is 10. If I am changing that priority to tg dot set max priority to 5. Set max priority to 6, just assume. Okay. Now, if I'm getting of what is the priority of these two tasks, these two threads which we are created. Now let's see. It is going to give off 5 5 only. So why it is going to give 5 5 means so from wherever we are calling up set max priority 6, so until that whatever the threads that we created before, those threads the default priority is 5 only. Okay, Default priority is 5 only. If you want to change the priority, default max priority, default priority also 5. If you want to change that, if you want to change for the next threads, let's say create of one more thread after this. Okay, it is of T3 T3 thread. If you want to get of T3 priority, T3 priority, then it will give off whatever that we have given T3 dot get priority. So until that, before whatever that we are giving, okay, before whatever that we are giving, what happened? Tg dot max priority, Tg dot set max priority equal to, I'm setting as this one, set priority. Now this is a normal priority, that is fine. Now try to get off Tg dot get max priority. It will give as whatever that we are set at 6. Okay, we can modify the priority of threads. We can modify the priority of threads. Let's say if I'm giving as 4, I'm giving as 4. Now let's see what is the third group which we are giving. The get priority is also, it is changing. Max priority before normal priority itself is 5. Now I'm changing that to 4. Now it is of below normal priority, right? Then whatever that max priority is there, that will return that. Okay. Now let's go to the document. We have so there are some important methods that are present in the thread group. Get name is to return the name of the group. Get max priority returns the max priority of a thread group. Max priority of a thread group. And set max priority to set the max priority. Default max priority is 10 for the group. Okay. Threads in the thread group that already have higher priority not affected. Threads in already, so these two threads are already created. For that the max priority is 10. So where we are setting the max priority again in the 14th line, whichever the threads that we are creating after this, for that only the max priority, the new one will be applicable. Okay, that's what this one, not affected but newly added threads, this max priority is applicable. Whatever that max priority is setting, that is only for the newly created threads only, not for the existing threads. Okay, that's what this one. Next, yes, create of one thread group and added up some threads and setting of max priority, and third group, third thread is added, and the priority is also modifying. Whichever we are setting the max priority, that only we are getting. Okay, the priority will be only for the place where from where we are setting that new priority. That's only for the newly created but not for the existing one. Okay, get parent, it is going to give the parent group of current thread group. Current or any thread is running thread group, if you want to get a parent of the current running thread group, then we need to call of get parent method. It will return the parent group name. Active count, so returns the number of active threads, number of active threads present in that group. It will count, it will give off active threads. Okay, and the active group count also, it is the active thread groups. Okay, if we have multiple subgroups also is available, we can add off subgroups also, guys. So let's say under system group main is there, under main group we have ibc group is there. Okay, like that, if you want to child, if you want to add up sub child group also, we can create any number of, if I'm creating one more, then let's say tg1. Okay, so then in that case, the main thread group contains of two subgroups. One is IBC group, other one is IBC group 2. So a group can contains of subgroups also. All that active subgroups counts will be given if you are calling of active group count. Now coming to locks, coming to these are thread groups. Now coming to the locks. So in case of multi-threading, before till now whatever we discussed, we are using of a synchronized keyword. We are using of a synchronized keyword to lock the any method. Okay, if you don't want to allow for two threads, if you don't want to allow to execute of simultaneously two threads at a time by one method, then if you don't want to allow that, then we can make that method as a synchronized method. Due to synchronized method, there may be a chance of getting off deadlocks, right? So that is bit careful. But now if you are using of locking mechanism, if you are using of locking mechanism, there is some provision is there to remove of that. It is easily we can it is easily we can maintain of order of execution of threads. Okay. Now let's see some example. What is a lock interface first? Lock is object is similar to implicit object acquired by thread. So while in case of synchronization context, so if you are using synchronized keyword, then thread automatically internally it will take the lock on that object, particular object which we are going to call up the method, synchronized method. Okay, to execute of any synchronized method or block, right? Now let's see. So this interface contains some methods. Okay, to take the lock, to release the lock, for trying for the lock, or some period of time waiting also. Okay, instead of instead of waiting that thread to for the lock, then we can make her if the lock is available, then only get the lock. Otherwise, you can do of other alternative operation. If you want to wait, then you can wait for the lock. Okay. If you want to wait for a period of time for the lock. Okay. If some other thread is already under execution, it is under execution of some other thread means then wait for 1 or 2 seconds. If the still it is not giving the lock, then you can do of some other alternative operations and try for other again after some time. Okay. Then like that, it is giving up some provisions to get off some locks. Okay, now let's check with some example. Okay, methods which are in present in the lock is wide lock. Okay, so what it will do whenever you are calling of lock method on lock interface, okay, there is a class called reentrant class, okay, that implements of lock interface. So it contains of some methods. Okay, now if you are calling if you are calling lock method on reentrant lock object, then if the lock is available already, if the lock is none of the thread is taking the lock of that method, then it can give the lock. Okay, and we can continue our execution. If the lock object is already locked by another thread, okay, if lock is there, it will take it. Otherwise, it will wait for the thread. Okay, then it will wait for to unlock that thread. Okay, whichever it is utilizing that lock. So until that is unlocking that, it will wait it. Okay, let's say sometimes if what is your situation? If the thread is trying for some lock, if lock is available, then get the lock and continue your operation. If the lock is not available, don't wait for the lock. Continue some other alternative operations. Go and continue your execution with other operations, alternative options. Okay, and don't wait. That is of by using try lock. Okay, to acquire the lock if it is available. Okay, it will acquire it. If the lock is not available, if lock is available, then the thread acquires that lock and returns true. So the try lock method will return true. True means the lock is available, you can utilize it. Try lock method will return false if the lock is not available. Okay, let's say if lock is unavailable, then this method returns false. Okay, and continue the execution of other cases. Continue its execution. In this case, thread never will be blocked. Okay, thread never blocked. If the lock is available, then only it can take it. Otherwise, it will not wait. It will execute of alternative operations. Okay, now instead of that, so what I want to do, I want to wait for lock. Okay, if lock is not available, then wait for 1 or 2 seconds. If the some other thread is whichever it is utilizing, if that lock is released, then utilize it. Okay, else continue your operation and try after some time again. Try after some time again. Okay, now like that, to acquire the lock, if it is available, if it is available, it will take it. If lock is not there, then thread can wait the specified amount of time. It will wait whatever the time that we are specified in the method, try lock method. It will wait for that. Still the lock is unavailable, then it will continue its execution. Still it is busy means, then only it will continue for the next operations. Okay, now we'll take off some example. Okay, and unlock method, we need to call to release the lock. If you're not calling unlock method, then lock will never release it. Okay, that is a problem again. Now let's take off some example. Lock. Okay, lock test. I have written off some method. Okay, so already in case of synchronized, whatever that synchronized test we have used, right? Synchronized void greet, inside that we are using of normal things, but the method was synchronized, right? Now I've created of one re-entrant lock. This is of implementing that lock interface. This is of implementing of lock. Now let's see, it is implementing of a lock interface. It contains of all the methods that are required. So lock, try lock with time, unlock, like that all methods are that are there. So the re-entrant lock is implemented for all the methods that are available in lock interface. Okay. Now go to I created object of re-entrant lock, and then inside whenever whichever thread it is calling of greet method. Okay, once it is started, I am locking it. Lock dot lock. If no other thread is having no other thread is taking the lock, then whichever it is entering the first thread, it will take that lock. So once it is taking, then within this code, so no other thread can enter into this part. No other thread can enter into this. Okay, now let's this is of lock l dot lock, and once this lines of code is executed, I will release the locked l dot unlock. Once we call this method, then it will release the lock, then whichever waiting thread is there, that will take that lock. Okay, now let's test of that. I've created one thread class, thread my thread equal to extending of thread display d and name. This is of common. So inside run method, I'm calling of d dot greet of some name. So here everything is same. The change is I'm removed of synchronized part and added of re-entrant lock. So whenever the lock is required, I'm calling of l dot lock. When it says that work is completed by that thread, then I am releasing that lock by calling of unlock method. So now the object is only one. Okay, it is of display d1 equal to new display, and I am creating of two threads. I have created of t1 thread with some display object and t2 also with some display object with some name. Now both threads is started. Now let's see. See, it is executing of the first thread. Once the thread is finished, then it is getting chance of that will release the lock and it will execute of another thread. Okay. Now let's go for a try lock. Okay. In this case, what it is doing, the another thread is waiting for the lock. So first thread it will finish the work and then it will give chance to some other thread once it is finished of first thread. But in case of try lock, if the lock is there, then only utilize it. Else, continue your other operations. Let's say I created one thread, my thread one extending of thread. So here also the reentrant lock object is required. We need to create object of that, and inside run method, what I am doing? If l dot try lock, if this method is executed by some other thread, Okay, if it is under execution of some other thread, then if it is execution under execution of some other thread, then don't disturb it. I will continue of alternative operations. I'm going to else block. Okay, try lock is returning false, means then that means that some other thread is already under execution. Okay, now in that case I will not wait, continue, I will continue of alternative operations. Let's see. See, first thread, yeah, see, I've given off, I created two threads, first thread and second thread. Okay, and both thread is started. Just assume T1 is started and then it is taking off lock. T1 already have taken the lock. Okay, if T2 is also trying for this lock, then this will return as false. Then in that case, it will go to else block. That's what is happened. First thread got lock. This is of it will give first thread. Okay, first thread got lock and performing of safe operation. Some message. Okay, second thread is also trying for the run executing of run method. Inside this, what we are doing? Inside this, it is checking of lock. A lock is already under execution of T1. Okay, then that is the reason it is going for else block. It is containing of alternative operations. Okay, let's say for example, try with try lock. So without these two, let's say for example, if without these two lines, okay, if two lines is commented, then all threads will be executed simultaneously. Then we'll get a irregular output. See, it is giving off irregular output. So if a lock is there, then it will not allow to execute of any other thread. Okay. So this is simple compared to the synchronized one, means compared to synchronization, this is the best one. Okay. Now try with some this one. Okay. If trying for lock, if it is available, it will take it. Else, it is going for alternative operation. Now try with some time. Okay. If lock is not there, wait for some time and then try it again. Okay. Wait for some time, and if still it is not giving, then you can release that. Okay. Now let's see here. Here also, what we are doing, I created a reentrant lock object. And inside run method, whenever I created of object of two threads, I created first thread and second thread, both threads are started. Okay, whenever first thread is internal, it is calling of run method. Okay, let's assume of first thread is started its execution. Okay, started its execution, and if it is trying l dot try lock of, okay, try lock of 1 second, wait for 1 second for the lock to release the other thread. If it is not released, then come out of that, come out of that, unable to get the lock, and it will try again, will try again. If until that, so what it is doing, inside that it is waiting for 5 seconds, after that it is releasing lock, right? Now let's see. In the, it is a do while, guys. It will execute, and then if all this completed, then while of true, it is, that means again it will execute. Okay, it will trying for the lock. 1 second it will wait, and then if it is not released, this part will execute, again it will try for the lock. Now let's see which thread will get the lock and which thread is waiting. Now let's see, second thread got lock, first thread is unable to get the lock, it is trying again, will try again, it is trying, and then second thread got, it is 4 times it tried, it didn't get the lock. Okay, and second thread after some time, second thread got released the lock. Okay, and first thread got the lock, and first thread is finished its work. Okay, this is of if you want to give some particular period of time for the thread to wait for some lock, then in that case it will wait. If it is not there, if you want to try for some other alternative operations, that is what that is what the try with some time. Okay, now next, try with some time. So same example whatever we have discussed, I have, it is available here. you can practice it. This of lock method. And next one more example. Yeah, all I have given. Okay. Now next try lock. It is for if lock is not if available, it will get. Otherwise, it will go for the alternative options. Okay. Now, now third one is not there. Let me add this as well. Try with some time. Okay. Try with some time example also. Try lock specified time. Example add of can add of this one change it to 11. Okay. Yes. This is what lockings. Okay. Now next concept. Next concept is what is that? Thread pool. Next concept is thread pool. Okay. Even in this case also, we are going to even in this case also we'll create of multiple threads if you want to perform of any specific task. Then there are some we'll call it as a executor framework. We'll call it as a executor framework here. Creating a new thread for every job. Creating, let's say I want to perform a 10 task, so the thread pool will create of for each and every job. For each and every job, if you want to create separate job or only one thread you want to finish off all the 10 tasks, like that we have thread pool concept is there. We even with that also will see of some examples. Creating a new thread for every job. Okay, what is my job? I want to job of whatever the job that you want to do will keep inside run method, right? So for every creating a new thread for every job may create performance issue, right? Let's say if you want to perform of 1 lakh issues means creating 1 lakh threads is creating 1 lakh threads is it's a not good way, it's a foolish way. Okay, so in that case we'll get up some performance issues and some memory issues. If you are creating 1 lakh threads means then we will get off some out of memory exception. There may be chances there. Okay, so instead of that we can create a thread pool concept. If you are going for the thread pool concept, it will create some 4 to 5 threads. So how many number of threads you want, it will create of that many number of threads, and only those threads will finish off all our work. Okay, to overcome this, this we should go for thread pool concept. Okay, if you're creating a, let's say 100 jobs is there means 100 threads, creating of 100 threads is not good way. Okay, in that case we can go for thread pool concept. Okay, thread pool is a pool of already created threads ready to do our job. What it will do? So thread pool contains already some threads. Okay, which let's say thread pool I have created with some 5 threads. I have submitted of 100 tasks. With that 5 threads only, 5 threads will finish off all the 100 tasks one by one. Okay, now, Java 1.5 version introduces thread pool framework to implement this one. Thread pool framework is implemented in Java 1.5 version. We'll call it as a executor framework also. We'll call the thread pool framework, we'll call it also executable framework. Okay, now how exactly it will create of let's create execute service of executors dot new fixed thread pool of 10. Okay, then in that case the 10 is it is of our choice. We can give 100, we can give 5 or 1 or whatever it is. Okay, it is of our choice. So in this case what it will do, it will create of 10 threads. Okay, it will create of 10 threads, and all threads will be available in thread pool. Okay, if you are submitting any task, then whichever it is available, it will take the task. Okay, the available thread in the thread pool. So it will take the task and then it will process it. Now let's take up some example also. We'll take some example. Yeah, we can submit runnable job by using submit method. We can submit of runnable job by using runnable. So we have runnable interface is there. It contains of run method. There is one more way is also there, that is called callable interface. There is one more way, callable interface is there. By using that also we can achieve it. By using that also we can call off these tasks. Okay, now let's see. Service dot submit of the job which you want to perform. Okay, at the end we need to shut down of this executable services. Then in that case all 10 threads which are available in the thread pool will be shut down. Okay, that will shut down the executable service, will shut down all the threads which are currently in the thread pool. Now let's take it off some example. Print job task. Let's uh, executable demo. Yeah, let's so what I'm doing, I've taken off one class. Okay, one thread. The job of this thread is print job. It implementing of runnable interface. Runnable interface internally what we need to do, we need to implement a run method. Okay, now just created of constructor, that's it for creating of object, nothing. And I have executing of some statement. System.println thread is started and it is waiting for 1 second and finish its job. Okay, now like this I have created of some group of I created some group of threads. Let's say in the main method I have created some, I have taken off integer, just assume integer array, right? Just assume int array a equal to, we are taking off 10 comma 20 comma 30, like that we are taking the values, right? In the same way I have created of some print job array. Print job array, so it contains of multiple print job array objects. Multiple print job objects. I created a 1 2 3 4 5 6 jobs. 6 print jobs I have created. All those things I have added in the array. Okay, now I want to execute of this array one by one. I want to pass the jobs of this one too. I want to pass jobs of all these print job arrays objects too to the executor service. Now, at the time before, for for each one we are creating, for each let's say equal to p equal to new print job, and this we are passing to thread t equal to thre thread t equal to new thread of we are passing of this p object. In before case, right? Before case we are passing of some IBC like this. Now what I'm doing, just I created of print job object. That's it. So internally I'll pass this one by one object to the executor service method. To the executor service by passing to the submit method, I'm passing this job. So internally that will execute of all the run methods for all these jobs. Now let's see. See, it is of execute service. Execute service of single thread pool executor. In this case, it is going to create of only one thread. It is going to create of only one thread, and all these jobs, all these threads will be executed by, all its tasks will be executed by single thread. All these tasks will be executed by, see, new single thread executor. I want to create a only one thread and finish off whatever the task that I have created. Now let's see. Thread pool is created and thread pool 1. This is the name of the thread pool. Okay. And this is a thread name. Okay. It is for all tasks, it is finished by single thread. So that's what we have created. That's what we are created here, right? Single thread. I want to create of only one thread. All this task will be finished by only one thread only, instead of creating multiple threads. Now this is one way. Okay. Now let's take it off one more way. That is of in the executor service. In executor service will use of callable interface. There is an interface called callable interface. Hold on a second. Now let's say if you want of if instead of executing a single thread, now new new mm, one second, fixed thread pool instead of new fixed thread pool of I want to create of let's say I want to create of 5 threads. I want to create of let's say 5 threads instead of let's say add of some more. Okay, I created of 5 threads, right? Now just assume they hi just to give off Raj. Okay. Now, in this case, to finish off all this task, to finish off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 10 tasks, I created a 5 threads. Okay. So please finish this 10 task with the five threads by creating of 5 threads. Let's see. Ram task is completed by thread 1. Okay. Ravi task is completed by thread 2. And Prasad task is completed by thread 3. Ashok task is thread 4. J task is thread 5. And again, Prasad task is taken by thread 3. Okay. Like that, it is going to take off. It is going to take off multiple. So, if whichever the task is completed by a thread, it will go for some other task which is in the queue. Whatever the task that is in the queue, it will take that. Okay. Next. Uh, next. Go to that next one. It is a fixed thread pool, guys. If you want particular period of particular number of threads if you want to create, then we can create that. Okay. Next. Next is callable future. Next is callable future. What is callable? Okay. So callable is also a, like a callable and future. So callable is also a like runnable. Okay. So in case of runnable, that run method we won't return anything. In case of runnable, let's go to run method. So where is the run method? So the run method is not returning anything. It is of void. Okay. Run method is of void. It is nothing is returning. Just it will finish the task which is available in the run method. Okay. But callable, but callable will return some result. Okay. If a thread want to return something back to the caller, if a thread want to return some result back, then in that case, callable is the best option. Then in that case, we should go for callable interface. We should implement of callable interface. Inside that, we have only one method that is called call method. Okay, that internally whatever the task we want to perform in that, inside the call method we need to provide implementation. So like under run method we are doing of our task. Same way, if a thread want to return some result back to the caller, then in that case we need to implement of callable interface. Okay, and that call method will return something the result. Okay, see, my work is my callable. It is implement of callable interface instead of runnable interface. I'm adding of callable interface. Okay, inside this callable interface, there is a method called call method. There is a method call method. See, and return type is compulsory. It will return something that will be of whatever you want it can return. Okay, if you want of integer, it will return integer. If you want of float, then it will return float. If you want of string, then it will return string object. Okay, that is of mm, anything that we can dynamically it can return that. Okay, that is based on the implementation that we are providing inside the call method. Now what is my task? My task is My task is I want to sum of the numbers like 1 to 10, 1 plus 2 plus 3 plus like that, 10 numbers. Okay, like that, how- all it will do sum and it will return some value. It will return some value back again. I want that value also. I want to print that value back again. I want to print that value. So the task of this one is printing of, let's say if I'm giving 20, I want to sum of all the 20 numbers. If I'm giving 100, it will sum of all the 100 numbers and it will return that value. Okay, that return value, okay, whatever that is calculated, the return value will be stored inside a future object. Okay, it will call as a future object. So from the future object, we will get the value. Now let's see practically. This is of, just assume like it is a run method, guys. But run method is not returning any value, but the call method will return some value. Okay, it is expecting, it is returning some value back to the caller from the thread. Now in the main method, I have created of multiple jobs. I created of multiple jobs. My callable of 10 means it will sum of 10, 20, 30. It will sum of all these numbers. 20 numbers it will sum, 30 numbers it will sum, 40 numbers it will sum, 50 numbers it will sum, 60 numbers it will sum. Okay. So I have created of array of my callable objects. Array of my callable objects I have created. Okay. Now, so once it is created, once this is created, some threads is required to execute of all this task. Okay, some threads is executor dot new fixed thread pool of 3 threads I have created. Okay, 3 threads I have created. So a thread pool will be created internally and 3 threads will be created inside that. So for executing of all this task, internally we are executing, creating 3 threads. Okay, now jobs dot job, first take one job and service dot submit of this job and then go for the next one. So once this is submitted, so it will return something back to the caller. Okay, that result will be stored in that result integer value is stored in the future object. That is the value is stored in future. From the future, if you want to get that value, we need to call of get method. Then only that result will come back. Then only that result will return back. Now let's see. Once all task is performed, then it will shut down that. Now let's see. I have created of 3 threads. Okay, 3 threads is thread 1, thread pool. Inside thread pool, 3 threads are there. Pool 1. Okay, 3 threads, thread 1, thread 2, thread 3. 3 threads is there. Okay, now thread 1 is taking off the first task 1 to 10. It is the sum of all these things is giving as it will execute that result will be kept inside here. Okay, and that result we are getting from f dot get. Okay, that is the first one. Second thread is taking of another thread for calculating sum of all these numbers. So third thread again it is taking of a third thread for executing of the fourth task. Again thread 1 is coming back. Okay, thread 2 and 3 are under execution. Now thread 1 is taking that one. Again thread 2 is taken by 50 and thread 3 is taken by the 60 value. So whichever is finished their task, it will not wait. So then it will go to the task. If any task is available, it won't wait. Let's say if you want to finish off all in one thread, no, then in that case executor dot new single thread pool executor thread executor. In this case only thread pool will create one thread and all will be completed by single thread only. See, all will be or finish, all tasks of all jobs are finished by single thread. Okay, now once it is finished everything, now service dot shutdown we need to call. In this case, all threads will be shut down. All threads will stop its from the thread pool. Okay. Now let's go and verify that. Now read it. So callable interface contains only one method. That is call method. Call method that contains of only one method is a call, and it throws some exception. Call method throws exception. if we submit a callable object, if we submit a if we submit a callable object to submit method, okay, submit method to the executor service, then the framework returns an object of type future. Then this will return an object of future class object, it will return. Okay, the future class object can be used to retrieve the result of callable job. So callable job will return some value, that value is there inside future, that value we can get from this future dot get. That's what this meaning. Next, yeah, think this is the, that's what this one, it is of single thread pool. I created of here 3 threads. If you want, you can create one thread like that, any number of threads you want, that means number of threads it will create and it will finish the jobs. That's what multi-threading, guys. If you want, you can search for some Google and then you can do of some practicing the multi-threading programs for better knowledge. Okay, this is for your understanding, later you can do of some practice, guys. And tomorrow I'll start off either collection or serialization. I'll start one concept. So tomorrow exactly I'm not sure. Tomorrow morning I have some deployment is there. So it's not sure about that I can take the class or not. Tomorrow I will give update on that tomorrow morning. Yeah, that's what for today's class, guys. We'll meet tomorrow again. Thank you. Yeah.